Hi, this is Joe Dietrich with Anesthesia, and we're going to talk a little bit about using our anesthesia machines for critical care ventilation. We certainly hope we don't have to go that route, but if we do, they should function very well with a few caveats. We do have two different types of anesthesia machines. The one we're looking at right now are the ones at Hedrick. They are GE or Datex Immediate Advances, and an anesthesia machine really has several different parts to it. Its primary job is to deliver oxygen plus an air or nitrous oxide mix, as well as the anesthesia agent, into a breathing circuit that can provide both manual or automated ventilation, and then also components to monitor these functions. Also, most anesthesia machines also have a patient monitor, and then we have a computer simply for our epic charting. So one of the big things that's different about an anesthesia machine is that it uses what's called a circle system. And it's a little different breathing circuit with the idea that the fresh gas flow coming into the circuit, and at this point I have a total fresh gas flow of 3 liters per minute, but I'm giving a minute ventilation of almost 5 liters, 4.5 liters per minute. That means that the system is recycling gases through the circuit as the ventilator goes. Now, the only thing we need to get rid of is carbon dioxide, and that is scrubbed out in this soda lime absorber. That soda lime has a definitive life, and as you can see, this one's already started to turn purple, so about 1/4 of it is used up. The more gas we recycle, the more the soda lime gets used, but also the less oxygen and air that we consume in the system as well. If we have to use one of these machines, the CRNA will do the checkout, and we will be in the building to help with the management of them, just because of the unique characteristics. So to kind of follow the gas flow, we have 2 adjustable settings. We have air and oxygen that feed into the system. Typically those would go through the vaporizers, but these would come off, and then they'll go into the breathing circuit and cycle into the patient lung. Here I'm using my bag as a test lung. In this situation, however, measuring the patient gas, which comes through this spirometry back into a gas sampling module, and then gives us our actual FiO2 and Fi and end-tidal CO2s, tells us that our fresh gas flow, which looks like it's 50-50 here, does not always match what's actually at the patient, and that's just due to the part of the rebreathing process. So one of the things that we'll mostly have to watch for is making adjustments in the fresh gas flow over time to make sure we're getting the desired FiO2. Also, if we start getting inspired CO2, that means it's time to change our soda line, and we'll have more of those available. It is a volume compensated ventilator, so it should adjust to some degree the ventilation based on the patient's compliance. Just kind of orienting you to the rest of the screen. This will tell the mode. We're in volume control ventilation. This is airway pressure. This is our inspiratory and expiratory flow, our peak airway pressure, our PEEP, our respiratory rate, our mean pressure, our minute ventilation, total volume, inspired and expired. These are the settings. These are the actual delivered results. We do have the ability to put up flow volume loops as well as pressure volume loops. Now, one thing you'll notice is that right now in the volume control mode, it is not showing a plateau pressure, which is very helpful in determining lung compliance. That is because this machine in the volume control modes and SIMV modes do not arbitrarily have the inspiratory pause set. So we need to set that to 10% of the I time. Once we do that, we'll start getting a little inspiratory pause. That will hold, and then we'll get our plateau pressure to show up in just a moment. And so as you'll see here, we've got just a little plateau at the top now, and that way we can get an actual true plateau pressure. The plateau pressure minus the PEEP will be our driving pressure, and that's the number that we want to keep kind of low. Now, recycling these gases is good because when the CO2 absorber does its thing, it converts the carbon dioxide to heat and moisture, and that adds moisture to the system. That helps humidify the patient. However, these are not designed to be run for long periods of time, and in time we may get accumulation of condensate down in the tubing, and that will have to be drained out. It's also recommended that about every 4 hours we just turn our fresh gas flows up higher, and that will help dry the system out. These have a coaxial single limb design. The inspired air comes in through the purple hose. The expired air goes through around the purple hose and the clear hose, and then hits this manifold through the to go out the expiratory valve and come in the inspiratory valve. This filter is on both limbs, and it's a 99.999% efficiency for both viral and bacterial. But in order to help keep our system clean, we will go ahead and use one of the blue HME filters, which also have 99.999% efficiency, and then we will put our gas sampling line behind it. That will help keep moisture out of our gas sampling line, but we do have a moisture trap back here also if that's necessary. Keeping this behind the filter will allow us to exhaust that to room air if need be. Now, a couple situations that can go on. If I get a leak, and I will create a leak right here, we will see that the bellows, which are kind of our internal reservoir, will progressively collapse. When that's empty, the system cannot create a drive. You will get an error that says unable to drive bellows. The first thing to do is look for your leak. Once you find your leak, you can fix it. We can refill the bellows back up, and we'll be back into normal function. Now, every time the bellows hit the top, we still have fresh gas coming in, and that extra gas goes out what's called the scavenging system, which is another difference from a standard ventilator. This is the scavenging system, which excess gas goes out into this purple hose, which goes into specialized suction. There is the ability to drain any condensation that accumulates down here as well, and that allows us to keep the system as clean and dry as possible. So those are the other thing is that these need to get cycled every 24 hours. It helps reset our flow sensors and make sure the system is working correctly. During that time period, the patient will need to be manually bagged, and another reason that we want to have the blue filter right on the endotracheal tube. These are capable of manual ventilation, but it's a very odd interplay of using this valve and the bag. If you have to bag the patient, just use a standard BVM. Now, what's similar about them? Well, we have most of the modes of ventilation that are available. You press the ventilator setup button right here, you can see our choices. We have volume control, pressure control, SI&V with pressure support, PSV Pro, which is a pressure support with an apnea backup, an SI&V in a pressure control mode, and a pressure control with a volume guarantee mode. We can set a peak pressure, and in the pressure support modes, we can obviously set an inspiratory pressure for those as well. We can adjust the IE as well, and so these really are pretty highly functional ventilators. Now, again, to manipulate our FiO2, we have to do that just simply by adjusting the fresh gas flows in small increments over time and allowing that to equilibrate in the circuit. We have multiple alarms that can be set through here. One of the things we'll want to make sure is that we actually have an inspired CO2 alarm setting so that if the CO2 gets exhausted, that we know about that, so we'll set that at about 5% or 5 millimeters of mercury. And there's inspiratory pressure alarms, tidal volume alarms that we can all have set. In the GE Advanced, as I'm showing you, all the gas monitoring is integral using the gas sampling line. When we go see the Draeger Fabious anesthesia machines at right, we will see that they have a standalone gas sampling that goes into the Philips monitor. Hope you find this helpful. So we are now at Memorial Hospital, and I'm going to walk you through the Draeger Fabious anesthesia machine and mostly highlight the differences from the machines at Hedrick Medical Center. As we zoom in, we have the monitor window. On the left side, we have the individual modes of ventilation. This does pressure support with apnea backup. We have our fresh gas flow controls down here. Those are also mirrored electronically here. The current total fresh gas flow is about 3 liters per minute, but our minute ventilation is 5. So again, we are recycling air. There is an oxygen sensor that's on the inspired port of the circuit, and I'll show you the actual gas sampling line. So this will be a redundant feature. If we want to make adjustments, all we have to do is touch one of the soft keys and our ventilation parameters come up. Of note, this one defaults to an inspiratory pause of 10%. So we go back to our home, we'll see that we do have a plateau pressure being demonstrated out of the gate. So once again, we can calculate our driving pressure if we desire to do that. This machine, mechanical ventilation, is driven by a piston-powered bellows, as opposed to the machines at Hedrick, which are driven by oxygen and actually have quite a bit higher oxygen consumption. Also, I'm using this bag as the artificial lung. I saved from using the filter here. But notice that even though we're on mechanical ventilation back here, the bag moves just to demonstrate how fast the ventilator is breathing and the relative indicator of depth. It is only just an additional tactile monitor. It's not actually necessary and part of the system. We do have also the gas sampling line, and one of the major differences between the two machines is that the gas sampling is not part of the anesthesia machine, but in fact is part of the Philips monitoring system with a gas module. If we had end-tidal CO2, it would show up here. We have inspired and expired oxygen, as well as the other vital sign parameters that can be attached to that monitor. It also has a scavenging system around on the side that has a drain at the bottom. This one has a drain catch going to the ventilator, so if we have excess condensation, we can take care of that way. Otherwise, the machines really work in a very similar pattern, where these are showing your actual displayed values versus your set values down here. We have alarms. Every once in a while, if you do get an auto peep alarm, the best way to fix that is press this auto set, and it resolves that very quickly. Otherwise, the overall function of the machines are very, very similar. And again, the CRNA will set this up, and we'll have the CRNA in the building anytime we're using it. Please let me know if you have any questions, and I will help you out. Thank you.